Hello,
Good morning.
good
Good.
morning.
Hello. Hello.
Hello, hi. Dear authors and invited guests, welcome to the technical session 5A. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being organized or held through Zoom from 19 to 21st February 2025. I hope you all would be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter would be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with the session, I would like to introduce you all to the chair for this session. We have Professor Robert. Professor Robert is an associate professor at the University of Zagreb, Faculty of Organization and Informatics. His research focuses on innovation in randomized algorithms, combinatorial optimization, computational intelligence, quantum computing, and information systems. With numerous publications in high quality journals, he contributes to the advancing algorithmics and related computational fields. We have other session chair Dr. Samiksha Shukla. She is an associate professor at Christ, Bangalore. Her research interest includes computation security, artificial intelligence, machine learning, data science, and big data. Her core expertise lies in computational security, artificial intelligence, and health related projects. She has 16 years of academic and research experience. She is a reviewer of the InterScience Journal, Springer Nature International Journal of System Assurance Engineering and Management, and IEEE and ACM conferences. We welcome our session chairs. Now, I would like to start with our papers. We would like to start with the first paper, that is a novel one-dimensional approach to human activeness measurement using a single PIR sensor. I would request the presenter to please start with your presentation.
Thank you very much for giving me this opportunity. So, am I audible?
Yes.
Okay. Can you see my screen?
Yes.
Okay,
Yes.
thank you. Thank you. Hello everyone, I am Dr. Taji Mohammad Niamatullah Akhund. I just completed my PhD in Saga University, Japan, and this work is a part of my PhD. This work is titled A Novel One-Dimensional Approach to Human Activeness Measurement Using a Single PIR Sensor. And these are the outlines. And I have expressed my work in this picture. Here we can see a room, and this is a single PIR sensor device which can sense a human or its activity in its sensing area but a PIR sensor generate a very small amount data, like just a motion. If the motion has, it gives 1, and if there is no motion, it gives just 0. But within this small amount of data, if we analyze it in uh, other way, we can get an idea of the activeness of human. So these are the summaries of my research. PIR sensor are very cost effective and privacy preserving device. Commonly it is used for motion detection in homes and offices. This study introduces a PIR based system for monitoring human activeness with a single sensor, focusing on and privacy conscious monitoring. This study introduces a mathematical model with using Laplace distribution and uses the parameter mu to define velocity distributions and capture activeness level. This work also implements real-world experiments that validate the mathematical model with the PIR sensor. Findings indicate potential improvement in understanding human activeness. So these are the contributions of this research. We made a numerical model, and we also simulate with that numerical model. Then we find a statistical relationship between the level of individual's monthly activeness and the histogram of the interval time. I will discuss about these uh, details, and we also validate this relationship with a practical experiment. So these are the motivation and background of the study. As days are passing by, the number of people who are living alone is increasing. Also, the people who are elderly and also living alone are also increasing. This data is from US Census Bureau, and from 2004 to 2020, we can see the percentage of elderly people who are living alone is increasing day by day. So these people are in danger of any abnormal activities, or sometimes in, basically, as I do this study in Japan, many old people who are living alone, sometimes they died unattended, and they also face various problems when they are alone in their home. So this work can help them to recognize their normal activity patterns. So these are the summary of related works in human activity recognition. Till these days, there are several approach which can recognize the human activities. Among them, some systems generate general alarming systems. Some systems work with image processing. Some systems work with gait analysis, and some systems works with uh, deep learning and machine learning. Also, IR sensor networks are used in several systems, and also in some previous approaches, multiple PIR sensor also used. But all of these systems has several limitations, like camera based systems has privacy issues. When if we want to monitor a people inside his or her own compartment, own room, then it may violate their privacy if the video is always recording, and later on in if someone monitored that video. And then IR and thermal systems also has some limitations, like IR sensors are sensitive to environmental factors and body temperature. And then comes to gait recognition system. For gait recognition system, the calculation is very complex, and also we may need to wire some sensors in our body. And for machine learning, AI, or deep learning based systems, it requires high processing powers, and sometimes it also require a very good data to analyze or big data to analyze anyone's movement patterns. And then simple alarm generation have some uh, limitations also, like the simple alarm generation systems has very few information, and this does not make enough data to analyze or recognize anyone's normal patterns. On the other hand, our proposed PIR sensor-based system offers a promising privacy-conscious, low-cost alternative among all of these systems. So at first I want to discuss about the what is the human activeness. Human activeness refers to the level and intensity of an individual's physical presence and engagement within a given environment. This concept encompasses the range of actions and behavior individual exhibit, from minimal movement associated with passive activeness to more dynamic actions. Activeness can be categorized into various levels like moderate, very active, or healthy life, overworking life, normal life, etc. So there are several challenges in modeling the activeness, because modeling diverse human activeness with mathematical procedure uh, has several challenges, because it is very complex if we want to recognize all the activeness. By focusing on activeness rather than activity, our approach provides a nuanced understanding of individuals' presence and behavior in a specific environment. The objectives are to develop a system for human activeness monitoring using a single PIR sensor and establish a mathematical metric for monthly human activeness, focus on privacy preserving methods, and emphasizing on cost effectiveness. To establish the statistical relationship between the practical monthly individual activity and the corresponding histogram of individuals obtained from a single PIR sensor through numerical and real world experiments. So these are our hypotheses. We hypothesize that using a single PIR sensor to detect human activeness will reveal meaningful patterns in the distribution of interval times between consecutive detections. So the intensity of human activeness can be inferred from these interval times. The interval times are the two interval uh, differences when the motion is detected. The first motion and second motion have an interval time. So we are talking about that interval time. So the intensity of human activeness can be inferred from these interval times, with a specific correlation between the individual's activeness parameter and the median of these intervals. This hypothesis suggests that analyzing the median interval times can provide insights into the level of activeness, enabling measurement and characterization of human behavior based on a PIR sensor data. So uh, the hypothesis is pictured in this figure. Like, we at first we if we collect PIR sensor data to detect human activeness, we will find a pattern in the distribution of the interval times, and then specific correlations between the individual's activeness parameter and the median of interval times will be found, and then we can recognize the level of activeness and normal human behavior. So at first, as I discussed earlier, we proposed a one-dimensional model. So if we let this is a sensing area of a one-dimensional area. If a human moves from this -1D to +1D area, then the sensor can detect. Outside this area, the sensor cannot detect. And if anyone makes any movement in this area, then the sensor will give a positive pulse or 1. Even if the person is inside the sensing area but have no motion, then it will also give a 0. So if a person have some movement after some time or between some interval times, then we can measure the intervals between two detections. So actually we will measure that interval times. So we make these assumptions, like this model assumes human is moving in a straight line with constant acceleration when it moves. It does not consider the factors like air resistance, frictions, and changes in directions. For the one-dimensional model, we assume the following fixed values, like human starts movement from x equal to 0 and the interval times is 1 second uh, at first. Then we propose this probability density function, which is derived from Laplace distribution, to recognize the or to calculate the velocity of a human's movement. So if v is the velocity, then this function will give us the uh, probability density function of our movement. And if we want to simulate that uh, PDF or probability density function, we must need to calculate the inverse cumulative probability density function, and we have derived these two inverse cumulative probability density functions. And after getting these two ICPDF or inverse cumulative probability density function, we plotted this histogram, which is uh, uh, applied with mu equal to 0. The mu is this mu. If the mu equal to 0 and total number of step is 60,000, then we find this histogram for interval times. And then we make a numerical experiment, and after applying a when we are applying a numerical experiment, we assume that a one day has 8 hours of working hours, and if a person has 1 second interval times, then he uh, at most he can make this number of working steps per day. So after assuming that, we make this simulation of the movement, human movement. These are showing the human movement into in this graph, and in the y-axis it is the positions, and in x-axis it is the time steps, where we assume mu equal to 0.5 and total number steps is like this. And after that, we also need to calculate the discrepancy and location by which we can calculate the crossing time. And finally, we can calculate the interval times. After making these calculations, we plotted several histograms with various mu values. So these are the histograms of interval times for several mu's from our uh, simulation. And we also regularized this histogram. Actually, in simulation we make many histograms, but here we are showing just 12 histograms, which are mostly similar with our practical data. Finally, we will compare with the practical data and simulated data. So
Dear,
here we
dear
use,
presenter, I
yes.
would request you to please conclude your research.
Uh, okay, so I want to take only 2 minutes more. So after making this simulation, we also make practical experiment with Raspberry Pi and PIR sensor device, and these are the device set up in my lab. And also this can detect like this is human. If human comes inside this region, it can detect. And after that, we also calculated the interval times from the real world data, and we collected data for 28 days. And these are the histograms of 28 days data And in the off days, which is Saturday and Sunday, we have almost no data, and in the working days there are a lot of pulses. And finally we have made these summative histograms of 28 days interval times from real world data, and then we regularized that histogram also. And the green one is the simulated histogram, and the blue one is the practical data. So both of these histograms are almost similar, and it is very similar actually. But to prove their similarities, we have applied EMD, or Earth movers distance. And we finally found that when mu equal to 0 0.7, then both the histograms matched more. And so finally we can make the conclude that if we collect data with PIR sensor and apply this method, if the value of mu is nearly 0 0.7, then we can say that the movement is uh, regular, or there is no chance to have any abnormalities. If the movement, if the mu value is differ from the normal values, then it will maybe a abnormal patterns. So we also make more experiments, and we suggest these values of mu's when it is normal, deterministic, or uncommon patterns of movements. So as the time is ending, so I want to make a very fast conclusion. And uh, so if you have any questions, you can proceed. Thank you.
Thank
Hello.
you. Thank you so much for your presentation. Moving on to our next presentation, we have the paper title Obesity Level Prediction Using Machine Learning. Dear presenter, could you please start with your presentation?
Yes, thank you.
Yes, ma'am. My name is Asti Wakani, and I'm delighted to present our research on obesity level prediction using machine learning.
Yes, we can see your screen. You may please start with your presentation.
So, obesity has become a serious public health crisis affecting millions worldwide and leading to various chronic diseases such as type 2 diabetes and cardiovascular conditions, and even certain types of cancer. Traditional methods for assessing obesity, such as BMI, have limited and do not provide an accurate and comprehensive assessment of persons' health risks. Our research aims to develop a machine learning based prediction model that enhances precision and effectiveness in obesity classification. The motivation from this research has been derived from the rising global obesity rates and the need for more data driven personalized solutions. Traditional diagnosis methods often fail to account for the complexities of obesity, which is influenced by numerous factors, including genetics, lifestyle, socioeconomic conditions. Machine learning provides a powerful tool for analyzing vast amounts of data, identifying key risk factors, and predicting obesity levels. By integrating ML-based prediction models, we can assist healthcare professionals for early diagnosis and intervention, ultimately contributing to preventive healthcare strategies. For the literature review part, we have considered many models of the previous, and from this we have found that the stacking and neural networks have consistently outperformed traditional statistical methods. So by implementing stacking ensemble approach, we combine multiple ML model to optimize predictive performance. Our key objectives for building this are making an ML-based obesity prediction model using ensemble learning techniques such as random forest, gradient boosting, support vector machines, and neural networks. identifying key predictors influencing obesity using recursive feature elimination to extract the most significant obesity risk factors. We have addressed the class imbalance by applying SMOOT to ensure unfair classification across the different obesity levels, ensuring model scalability and interpretability to making it applicable for the real world and healthcare interventions. We have used two data sets over here. The data set one contains the data of the people from Colombia, Mexico, and Peru. It has 17 attributes and 2011 and 1111 instances. The data set two is taken from the CDC data set of children and adolescents aged from 2 to 19. It has 16 attributes and 5,840 instances. The data pre-processing was done by handling the missing values using SMOT to ensure that no small classes so feature scaling, standard scalar, standardization, and encoding. We then used recursive feature elimination used to identify critical predictors of the obesity, and due to using these, we found that the most important factors were BMI, age, physical activity frequency, time using technology, high calorie food consumption, which played a crucial role in the obesity classification. We made the model through stacking ensemble model, integrating 4 different machine learning algorithms: random forest, gradient boosting, support vector machine, and neural networks. The stacking model utilizes logistic regression as the meta model to enhance performance, and our results demonstrate the effectiveness of ensemble learning in obesity prediction. The model performance across the dataset is as follows. We also made a model for individual algorithms and then made the model for stacking ensemble. And the accuracy that we received for stacking model was 96.6 on the first data set and 89.9 on the second data set. The key insight and contributions. Our model has given high accuracy. We have used feature selection, SMOOT to reduce the imbalance, and ensemble learning to improve the performance. We can improve this model using explainable AI and real-time health monitoring to implement it in mobile apps and real-time applications. To conclude, this machine learning has immense potential to revolutionize obesity prediction and prevention. Our research demonstrates that stacking ensemble models significantly enhance prediction accuracy, enabling personalized health interventions. By integrating advanced data preprocessing techniques, feature selection methods, and ensembling learning strategies, we provide a scalable and interpretation solutions to obesity classification. Thank you so much for your time, and we truly appreciate this opportunity to present our research. Let's work together for a healthier future. Thank you.
Thank you. Thank you so much for your presentation. Ma'am, any questions?
So I would like to ask the presenter, what were the key parameters she has used to build the model?
Ma'am, so the key parameters that I used was the BMI, age, physical activity frequency, the calories, food they consumed, and the time spent using technology.
What is the accuracy level of your model?
Ma'am, on dataset 1, it's 96.6%, and on dataset 2, it was 89.9%.
From where you collected the data set?
Ma'am, we got the dataset one. First was from Kaggle, a paper published that dataset, and the dataset was published with the paper. And the other one we got from CDC. The Center for Disease and Control in USA. So we got
So,
it from the website.
so CDC website, you got the data?
Yes, ma'am.
Whether your model was validated by someone?
Ma'am, you mean my supervisor?
Not supervisor. See, this is the model for medical prediction, right?
Okay.
So your supervisor might be from maybe computer science.
Ma'am,
But
Yes.
sorry, can I? I am a
yes, yes,
supervisor.
yes.
I'm a supervisor of Husky. I'm a Dr. Hardik Jaiswal. So this is an interdisciplinary project. In our project, we have the number of peoples from other field also. Let's say one from the doctor, MD physician is also involved, where he guided us what is exactly the level of obesity. So you can consider this model is not validated by the process, but yes, whatever the data set we got and we corrected also. So you can consider this, yes.
Okay, sir. So have you got like there are already existing models. Have you compared your model with them and found that where your model is better and where other models are better?
Yes, ma'am. Actually, what the data set that we have collected from the internet, that is from the Kaggle data set. So already on the Kaggle, the paper was uploaded, and from the same we compared the our data set from our model and with the same data set.
I mean to say, what was the output they were getting and where you have improved upon?
Yes, we were improved in form of accuracy, where then in the previous paper, the accuracy reported by the researcher is near about 85 or 86 something.
Okay. Okay. Thank you.
Thank you. Thank you so much for your presentation. Thank you, ma'am. Moving on to our next presentation.
Yeah, thank you everyone for the wonderful session here. I'm gonna go due to the time constraint, I will go real quick because I'm in different time zone. So, obesity risk prediction, this is similarly to the previous presenter, presented. So obesity is a huge problem right now, right? Especially with the becoming a huge, problem, especially with the young adult, right? Concerning, it requires risk predictors and intervention approaches. The study, integrate traditional lifestyle similarly to the previous speakers, but ours we compare with various types of models, machine learning models, to see how can that be prediction can be improved by also looking into some of the social media metrics like obesity. It offers insight to the targeted preventive strategies. It's also find the emphasis of valuable incorporated of social media data into predictive model highlights its multidisciplinary approach to the public health crisis. So in the understanding of obesity crisis, what we did, why is obesity growing into concern, and why accuracy prediction is matters, right? Excessive body fat can lead to various types of cardiovascular diseases, and then also diabetics and certain cancers. Global obesity rates have rippled since 1975, with projected an exceeding of 1 billion cases by 2025, according to the World Health Organization. In 2020, high BMI contributed to the 4 million deaths and 120 million disability adjusted life years in worldwide. Why accurate prediction matters is that it helps identify high-risk populations and optimize resources allocation for a public health intervention. And also, it focuses on traditional risk factors, including diet, physical activities, genetics, by social media behavior may also be predicted. So in the social media obesity's prediction, social media provides vast amount of health information, behavior, physical activities, diet patterns, and machine learning can give a really insight of risk factors to it. Again, no, medical doctors involved over here. This is just to see which machine learning model detect best options for obesity prediction. An ethical concern, of course, the data is a huge problem. Data it's not only used, but it's very difficult to find the data. So information must be consensual due to the various types of cybersecurity laws and policies, various types of privacy policies, and responsible for AI use must be addressed. In the research goal to identify the most predictive social media metrics for obesity risk, develop machine learning model integrated lifestyle and social media, and inform targeted prevention strategy to mitigate obesity, especially in young adult. So if you see the proposed model, we get this information from social media, behavior changes, we process the data, we feature the extra data, we training the model has been trained, grounded, perform, use the classifier, extract the data, and get the best prediction. So where do we get the data? Experimental setup has been set with of course the Kaggle, because nobody will give you the free data except in a Kaggle. So use the Kaggle data where you used BMI, activities, diet, and life. These are the life factors, and also social media habit to obesity. Nutrition lifestyle data details on the diet, exercise, and daily habits. And the goal of this integrated traditional and digital data from comprehensive obesity model. So in this experimental setup, we use data cleaning, we remove duplication, correct inconsistency, and handle misuse of the value of the mean data, means and medium numerical model for categorize. In future emerging and normalization, we convert lifestyle by quantifying factors by calorie intakes, physical activity frequency, normalize number future by using mix and mean and max and scaling. You use traditional text processing and NLP for social media data. We use a sentiment analysis, discuss the frequency, and the future session and correlation analysis is identify the key prediction using by correlation coefficient and randomize forests to improve the scorecard. So here is the correlation analysis for various features. And in the experiential model, we use support vectors, XGBots, and decisions tree. In support vector machine is effective in a high dimensional space, and XBoost is grant boosting for improving accuracy. And decision tree, of course, is simple and interpretable. In the training process, future including calorie intake, physical intake, and sentiment scores and health discussion. Pretty simple process here. A target variable represented obesity risk with Y, and also model learned complex relationship between input futures and obesity. Model also optimize careful across validation, prevents overfitting, ensuring generalization. Iteration fine-tuning, we improve prediction accuracy, and finally the performance of it. Within the experimental setup, we looked into the accuracy, which to measure the proportion of correct prediction of obesity risk cases. We also look for the precision, assess the correctness of the position obesity risk prediction. We also used look for the recall, evaluate the model's ability to detect all true obesity risk cases. We use F-score harmonic means of precision and recall, balancing correctness and completeness. And then we use a k-fold cross-validation, dataset split into k-fold, model train on k1 fold and test on the remaining fold, average performance across all folds, ensuring robustness and generalization. So if you see what is the experimental result here, SVM, X, Ghost, and DT over here. And definitely performance of ML models of traditional data, comparisons to the model accuracy and model precisions, and F scores and recalls. And here is a comparison model of the accuracy. So finally, we can conclude that X post, outperform the other model across all data sets. Combined traditional and social media improvement accuracy significantly. Calorie intake and sentiment score, calorie intakes and sentiment scores emerge as a strong predicted features. And here is the accuracy, sorry, one stuff number here. And key finding, over here is the traditional factors remain, primary predictors of obesity risk. Of course, calorie intake improves 0.32, physical activity frequency improves 0.2.8. Social media behavior provides valuable insight like sentiment score, importance of it, and health-related decision frequency of 0.17. Integration of both sources improve prediction accuracy, highlights a multifaceted approaches to obesity risk assessment. Importance of public health, which is insight can be personalized campaign, promote health and eating and physical activities. And of course, we need to be mindful about our data, how the securities of the data and information consent of the users, and transparency and critical when using social media. And in conclusion, significance and impact of this is bridging traditional and digital health data in extent obesity risk research by incorporated social media behavior, inform public health strategy, insight support, targeted intervention, particularly from young adult and engaging in social media, limitations and future research, data bias and collection challenges. Enhancing accuracy through wearable tech and mobile health apps would be a huge one. Expanding prediction model, right? Incorporating genetics, environmental, social economies factors would be, or a holistic assessment would be a great contribution in addition to it. And beyond obesity and adaptability model of diabetics, cardiovascular diseases, mental health, well-being. And that pretty much conclude our research. And thank you very much. And again, I'm part of the St. John's University of New York, along with my colleagues from Rider University and St. John's Universities. Thank you very much.
Thank you.
Hello.
Thank you for your presentation.
So I have one question here. You have used three algorithms. As per you, which algorithm is best? You have already shown that accuracy is good and all those things, inclusive of all the parameters. Which one you feel is the best one?
XBot definitely is the outperform all the model if you compare it, if you see the comparison to it. So definitely XBot is again, based on the performance of the data that you write. If you see the XBot outperform all models, we use three models, algorithm support Vector and DTs, and XBot definitely was the one who has, accuracy level high.
Okay, thank you.
Thank you. Bye-bye.
Thank you. Thank you so much for your presentation. Thank you, ma'am. Moving on to our next presentation, we have our paper title, Predicting Risk of Future Hospitalization in Patients with Type 2 Diabetes, Mellitus, and Cardiovascular Diseases using Machine Learning. Dear presenter, could you please start with your presentation?
Yes. Can you hear me?
Yes, we can hear you.
Okay, let's start. So, hello everyone. I'm Professor Alexey Kramov from New Uzbekistan University, and we work together with Republican Specialized Scientific and Practical Medical Center for Cardiology. so with cardiologists, to build a prediction models to predict the risk of future hospitalizations in patients with both type 2 diabetes and cardiovascular diseases. So the importance of assessing hospitalization risks in such patients is based on that we need to decrease the involvement of hospitals in treating these patients and mostly do this ambulatorily. And so we don't want for them to have complications along the way. So we are analyzing one medication, which is empagliflozin, and its impact on patients. So we collected the data on 260 patients. Half of them took empagliflozin to help both mitigate their type 2 diabetes and their heart diseases. So we wanted to analyze the data and find what are the key features that mostly impact future hospitalizations. And after finding those features, to build a predictive model using linear regression model. So the economic impact of hospital readmissions for diabetes patients is obvious because their number increased since we have the COVID and other diseases that increase the risk of getting diabetes and getting it earlier in age. So hospital readmissions place a significant strain on healthcare resources, and we want to improve that situation by controlling the patients and admitting only those with a higher risk so we can pay more attention to them so they can not get into bad conditions. So we analyzed 260 patients from the cardiology center that I'm working with, and they provided us with more than 100 features, descriptive features on each patient. We employed a series of statistic tests like Kruskal-Wallis test. We also used ROC-AUC metric, and we used Pearson's correlation. So we used all three of them to determine which one is better in feature determination, which one is better for extracting important features. And we used the generalized linear models to build the predictive model. So we randomly divided our set into training set into which we have 80% of patients and test set with 20% of patients. After training the linear model, we tested it on just test set and provided a ROC-AUC on the test set only. So the major difference between such approach and just getting data from any database is that every region has its own geographical sensitive information like diet or weather, other components into everyday life that can affect our patients. So we measured a lot of features, and then we wanted to find which ones are the best ones to predict the future hospitalizations on. So we built three predictive scores. So we have to extract important features. One of them is Pearson correlation. Another one is Kruskal-Wallis, or also known as non-parametric ANOVA. And the third one is we multiplied ROC-AUC measured on pair of the value of the feature and the future hospitalization vector. And we multiplied by 2 and then subtract 1. So that one looked more like another correlation, which was not linear correlation. So, and this approach helped us to extract more important features than other approaches could do. You can see that, for example, for AST, aspartate transaminase, Both Kruskal-Wallis and Pearson's correlation marked it as not important, but our approach found it as more important than other features. So key features for readmission risk were BMI, age, blood pressure readings, and other parameters. We will see them in the model. So that's the linear model, generalized linear model that we trained. And you can see here coefficients of each of them feature and standard error. We didn't use normalization of the features because generalized linear model does it itself. The coefficients are responsible for normalization, and we have a constant which is responsible for subtracting the mean. So our ROC out on the test set was 89, more than 89%, and we compared it with the other related works that are also referenced in our paper. So other related work in the same field was 74% and 82% correspondingly. So it means that our model outperformed existing papers. And thank you for your attention. So if we have any questions.
I don't have any questions.
Thank you. Thank you so much for your presentation. Moving on to our next presentation, we have our paper, UAV path planning for enhanced connectivity in environment with limited infrastructure using DDQN. Dear presenter, could you please start with your presentation?
Hi, can you hear me well?
Yes, we can hear you and your screen is visible.
Okay, thank you. Thank you for the presentation. Well, I'm a professor in the informatics department in the Federal University of Viçosa in Brazil. And I'm the second author of the paper, UAV path planning for enhanced connectivity in environments with limited infrastructure using DDoKN. And well, we know that the use of UAV in several applications, there are several applications today, it is increasing, and we have different cases of using, and also, for example, we have the possibility of the communications. Well, in long distance missions, that's not enough to communicate with the user equipment, and there is the necessity of using other using infrastructure like 5G network and or even Wi-Fi network. So the idea is of the path planning is to make the UAV to adapt its trajectory, its path, to enhance the connectivity. So okay, so what we propose is a machine learning model that provides worlds with better connections. It may have a small cost in the distance that it would that should the trajectory that it would increase on the trajectory, but we have better connections. And to this, the learning model that we use is it's based in the reinforcement learning model, where the agent take an action over the environment and observe and the next state and get a reward. And the DeepQ network, they use the neural network to make it better, more scalable, and we have the double DeepQ network that even improves that by using two neural networks, using a target network and that use it to evaluate the actions, and the current network that use it to take the action. So also we have the experience replay buffer that's used to instead of using just the most recent results, we can have the past results using this replay buffer so that they all will influence on the results. So using this, we can improve stability and accuracy of the learning. And okay, so we have both networks. Okay, and also in the methodology, we have the to 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 to, to model the states. We have this the signal of the power, the reception, that we use the Friese equation for the IEEE 802.11. Uh, so we are based on these technologies. So we can, according to the signal, we can detect if the device is going further from the the base station. Well, moving forward, this is the simulation environment. We can see here there are many possibilities where we have the green circles showing the power, the reception power of the signal. And but in this work, we model the scenario as we have this example of 160 meters by 160 meters, and to make it not to diminish the amount of data and to improve the efficiency of the training, we model it as at 80 per 80 grid cells. And in the left side can see here that the the one that is we use it we based on that, that's the one where the antennas are placed in the corners of the square. So we have an area in the middle that's not offer connection, and the agent should cross this by avoiding disconnections. Also for the training efficiency, we did a simplification, changing the Euclidean distance to a Manhattan distance. So if you check this image on the left side, when we use it, the Manhattan distance, we have this image, the left side. So I don't know if my mouse can be seen by you, but there is a blue blue point here. That's the objective, where the device should reach, and then the origin of the trajectory may be any part of the map. The difference using the Manhattan distance, we see here that there is this the disconnection, the edge between connection is a straight line because of this Manhattan distance. The difference is shown in the figure in the right, with the red dots showing the difference between the what we have seen in this figure, in this slide, and the figure of this slide. So there is a 2.3% of the region that there is no coverage. But anyway, when we consider the Manhattan distance, it's not a big problem, because the agent was going to avoid this distance in these dots in the border, so it would also avoid this connection. Yeah, and when moving to this to the results, we see here some examples of the route that was done by the agent. So in this case, we consider a fixed objective. So is the blue dot that is shown here, the end of the trajectory, and this distinct source of the trajectory. So we can see here in the lower part of the map, and the second one in the higher part of the map. And we can see here in both cases the agent avoids the red part that would cause a disconnection. Here is another result showing now a comparison between what we observed in our model and another model that, well, just a simple model that would minimize the distance from the origin to the destination. So we can see here in red the points where in the left part, in red the points where the device was disconnected because of this minimization of the distance. In our model, it would, using the same map of this in this figure, it would avoid the disconnection by going through the way. It's the same idea here of the antennas being positioned only on the corner of the map. This is another result. The idea is the same. I'm just showing here that in this case may be different from what expected from a distance minimization where we expect a linear trajectory, but this is a result of the Manhattan distance. So it would be the same, but the distance is the same. But instead of showing that pattern of a staircase, it have this 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 other pattern on the trajectory. But anyways, we see that it can again avoid the middle part of the screen by going out, around the disconnection area. Well, there is here also for just to make an average of the many we run that evaluation in several distinct trajectories, just changing the origin, and to make it easier to evaluate, we divided the area in regions like this being shown here in the upper figure. We divided in 16 figures, and we averaged the number of steps that's and also the connection rate for each one of the regions. So for example, considering that the destination point is in this Q11, we consider that, well, for each one of the 16 other regions, well, the 16 regions, we have different number of steps. Of course, we expect to have more steps on the Q1 because it's further and have to go around the disconnection area. So we can see here that it has, comparing in blue the distance minimization model, and in orange the proposed model using the DQN. So we have more steps, but if you compare with the figure in the right, we see that the in this model we have all the connection rate is 100%. So in all examples that we have a connection rate of 100% when and while the minimization distance minimization, we can have many disconnections during the trajectory. In an average, we have this 33% more steps, but with the benefit of having constant connectivity. We have other work in progress, and we are now trying to make it work for to make the goal, the objective also variable, not only on one point. and we are applying these different techniques. The universal value function approximation, it's in this case we have the destination also apply in the state of the network. And there is the hindsight experience replay, that this is more for making the training more efficient, so we can use even episodes that have not been completed. We can use that to to see how it would what would be the rewards if the goal was in different places. So in this technique we can make it more efficient, the training. And also the meta learning, that is the idea to, even in untrained instances, we can in different destinations, and even in different scenarios like this, with different position of the base stations. So this is the work in progress, and if you have any questions, I can answer.
Thank you. Thank you so much for your presentation. We have any questions, ma'am? Okay, moving on to our next presentation, we have our paper title, Virtual Customer Service Assistant for University Students. Dear presenter, could you please start with your presentation?
Hello, right.
Dear presenter, your screen is visible. Could you please start with your presentation?
Hello,
Okay.
can you hear my voice? Hello?
Yes.
Great.
Secretary, so please continue with the presentation.
Okay. Good afternoon, everyone.
Please continue. Good afternoon.
It is a pleasure to be here at ICICT 2025. My name is Sacrificio Junior. I am a student of information technology at the Catholic University of Mozambique, and I'm here presenting this work with my co-author, Dr. Mohamed Gulan Lorgat. But before we continue, I would like to show the presentation structure. So we'll start by introducing, and we'll go to the related work, design of the chatbot, implementation, demonstration, conclusion, and the references. So the number of students has been growing at the Catholic University of Mozambique, so which is great, but this growth comes with a challenge. Long lines, slow administrative process in obtaining information, or when students need information. So we asked ourselves, how can we make things easier for students and staff? So we had this solution in our mind, that we can create a virtual assistant that can respond to students 24 hours a day and 7 days a week without the need to be in person. But before we developed the chatbot, we needed to do some research. See what other researchers are doing, or how they are doing to solve this problem. So the first work was conducted by Maria in 2019, where was developed a chatbot for the Instituto Superior Técnico, facilitating access to academic information by integrating with the Phoenix EDU API. They used Flow, and the chatbot provided data on courses, subjects, and it could send notification. And it demonstrated its high usability and superior performance in user tests. And work was conducted by Livas and other authors in 2021, where they presented an intelligent chatbot designed to quickly respond to students' queries using Google Dialogflow natural language understanding platform. They integrated it with Slack, so the chatbot could access the spreadsheet of questions and answers provided by instructors to deliver instant responses. And tests showed that the chatbot significantly improved the efficiency and accuracy of academic responses, while also being easily customizable and integrable with other relevant technologies. And finally, we analyzed the work of Elami and other authors. And this work was conducted in 2023, where they proposed an academic guidance chatbot and integrating it with natural language processing and artificial intelligence. And it was accessible via mobile application. So the system aimed to reduce the need for in-person meeting and increase the students' interest in advanced technology. And the test also showed that the students found the chatbot easy to use and effective. And after we did this work of analyzing other works, other researches, we jumped to the next step, that was design the process of designing the chatbot. But before we designed the chatbot, we had three musts. That chatbot must be simple and intuitive, comprehensive, and easily to access. People could access it in a platform where they are comfortable to use. And we have our functional requirement and non-functional requirement. And the functional requirement are simple, and it must display a welcome message when a user starts a conversation. The chatbot must show options, and the chatbot must be capable to answer automatically frequently asked questions. And after that, we jumped to the implementation process. So the implementation is where we started to create our chatbot, to make sure that chatbot was really answering the question of the students. And the first thing that we did was defining the intent, the intention of the users. So the first thing was to make sure that when a user sends a message, a greet message, like, for example, hello, hi, what's up, the chatbot must respond to the user with a welcome message, but not only a welcome message. So that came the second thing that we did, that was configuring the welcome message to be displayed with some option where the student could choose if he wants to ask a question, if he wants to cancel a conversation, or question related to courses, for example. These are static options. And the thing that we did was the implementation of the knowledge base. Why knowledge base? Because if a student has three options, he can ask a question, he can ask about courses, ask a question, he can type the questions manually, he can type the question as he has the question in his mind, and the knowledge base is capable of returning the response based on the question that was typed by the student, different from the options that are static, like about courses. So that's why we implemented the knowledge base, where the chatbot can fetch the data and return the data to the student. And the last thing that we did was integrating it with WhatsApp. Why WhatsApp? Because most of the students at the University of Mozambique, they use WhatsApp. They have access to the WhatsApp. They use WhatsApp daily. So if we integrate it with WhatsApp, That means the users will feel comfortable to use the chatbot in WhatsApp because they know or they use, that's the platform that they use daily. And right now I'm going to demonstrate some screenshot of the chatbot. So I think I hope you are seeing my screen right now. Are you seeing the screenshot?
We are on the implementation slide, right? Right now.
I didn't. Oh, okay, 1 minute. And now?
Yeah, now we can see the screenshot. Yes.
Okay. So there's a message started by the user. So when the user start the conversation, the chatbot gives two options. If the user understands Portuguese, he will choose Portuguese. If he understands English, he will choose English. So after choosing the language, the chatbot will give the welcome message and the three options. He can ask a question, he can see about courses, he can cancel the conversation. And if he chooses courses, for example, the chatbot will return the information about courses and the list, and these lists are placed as an option. If he click one option, the chatbot will return the information about that course. And the chatbot also displays other options. If the chatbot answers, then the chatbot will show the main menu or cancel the conversation. And then if he go back to main menu, he'll see the three options that he saw in the first iteration. And then he shows ask a question. When he clicks ask a question, he can type the questions. The chatbot has the intelligence to search the response or the answer on the knowledge base, and then the chatbot retrieves the answer, and before that it gives a feedback that is typing, so to let know the student that the chatbot is processing, is doing a work. And then he can ask another question. The chatbot will also show an option to exit or to continue asking question. And then if he click exit, the chatbot will give a message. Of course, here you can see. We'll give a message that it was a pleasure to assist you, and the conversation will be ended. So this is the demonstration. Now we can go to conclusion, and we developed this chatbot to reduce the wait time in the administrative office, and to make sure that students can get information without waiting or being long quiz or long line. And for future research, we aim to conduct tests of the developed chatbot and expand the chatbot functionalities. We would like to make sure that the chatbot can give all the information that the student wants. If he wants to know about the payment plans and the student's grade, the chatbot must be able to show that inside of the integrated platform that is WhatsApp. So thank you for this opportunity, and this was the presentation that we prepared.
Thank you. Thank you so much for your presentation. Ma'am, you have any questions?
So I was in half of the presentation. So it's okay. I just have a query. The chatbot which they have created, whether they have checked it with any existing one.
I understand.
What was the title of your presentation, sir?
The title of my presentation.
Yeah.
Okay. Virtual customer service assistance for university students.
Okay, that's what my question was. But there are existing models available. How you place your model in compared to those models?
The question is how the model that we developed is different from others. Is that the question?
Yeah.
Okay, I understand. One of the key difference is that our chatbot, but most chatbot that we analyzed, they weren't capable of, for example, the student couldn't write his question or type his question. There were only static options, and so if he had a question that that is not on the options, he couldn't type that, and that is one of the difference. And another is time of response. So the chatbot that we developed can answer the student in less than 5 seconds. So those are some key differences. And we integrated with the most used platform for messaging in Mozambique.
Okay, thank you.
Okay, thank you.
Thank you. This brings us to the end of our presentations. Ma'am, I would request you to share your insights and feedback on our presentations today.
So it was wonderful to listen to the new research, and I can see there are many students who are contributing with their professor. So it is good to bring some research culture among the students from the college, their undergraduate classes, etc. That is something which is new, which you people are coming with your conference. Thank you so much for having me here.
Thank you, ma'am. Thank you so much for your valuable feedback. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 10th version of the conference and all the previous 9 versions of the same. We'll be happy to have you in the 11th version as well in 2026. All our presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication would be live within 6 months. Kindly cooperate with the team of ICICT 2025. I also thank our session chair, Professor Sabiksha ma'am, for chairing the session. A token of appreciation to the chair on behalf of the team ICICT and Global Knowledge Research Foundation and partners. Thank you, ma'am. Thank you for your valuable presence.
Thank you.
I would kindly request all our participants to please switch on your camera so that we can have a quick snapshot of the conference. Thank you. Thank you so much, everyone. Take care and stay safe. Thank you.